Master's theorem. So there are two types of theorems. One is both for recursive relations, that is subtraction one, and another one is the division one. So here the recursion is being done on n minus some constant like n minus 1, n minus 2 elements, and here it is done n divided by 2, n by 3, and so on, like that. Like this is for TOH, Tower of Hanoi, and this is like binary search. Okay, so for these cases we see Master's theorem and extended Master's theorem. So first, taking this into consideration, this should be the format in which our question should lie. T of n is equals to T of n minus b plus big O of n power d. Okay, now when it is subtraction, we have to see for the value a. Okay, means a is greater than, less than 1, or equal to 1, or greater than 1. Okay, if a is less than 1 and this value is very small, which when multiplied with this value makes smaller than this. So if this one is bigger, then it is the answer, means T of n is equals to big O of n power d. Similarly, if a is equal to 1, this is 1, also this is to be means this has to be considered. So the total is like t in Tn we are having n power d, in n minus b we will have n minus b to the power d. So it's like doing recursion, and every time we are multiplying by n, so it is n times recursion of n power d, means this value will again come inside this, so it is n times in this value n power d, so it is n power d plus 1. Now if a is greater than 1, means this value has a, this thing has a value along with this. Okay, so now both are to be considered, so therefore n power d will remain same, and at the same time we need to multiply value for this. What is the value for this? Value for this is a times n power b. Why this value? Because the function is being multiplied by a times, therefore dot a, but what is the power, like how many times a should be multiplied? So we can see that here we are subtracting b every time, which is same as n by b, so a power n by b into n power d. Now coming to second case, it's division. So a n power b, f of n, there should be a polynomial, and then log n, that it should be log n to the power d. D we can see greater than equal to 0 or less than equals to 1. Okay, so considering first d is greater than equals to 0. Now calculate, first step is to calculate n log a, base is b. Okay, n to the power log a base b. Now if this value, we have to compare this value in log n by b, we need to see n log a base b. So here what we are doing, we are comparing f of n, the polynomial function that we are having, f of n with n log a base b. If f of n is less than this much, this value is less, making this value less, but greater than this is the bigger value, then the whole answer becomes that, means t of n is equal to theta of this much. Okay, similar means this is the condition for d greater than equals to 0. Same for d is less than equals to 1, means all values of d. next case is f of n is greater than this n log a base b value. F of n is greater, this is greater, means this whole function will be greater, means whole complexity. So t of n is log n, f of n log n base d. This is for d is greater than equals to 0. Okay, so now if d is less than equals to 1, then why do we need to consider this part? We won't consider because it's like negligible when compared to f of n. So that is discarded. It is only theta of f of n if d is less than equals to 1 and this condition is satisfied. Now the last condition is f of n is equals to n log a base b. Okay, so this part is itself equals to this much. F of n is n power log a base b. Now we are multiplying it with log n base d. Generally what we see is n by something is there, n by 2, then we generally do it log n base 2. So similarly here we are saying time complexity of this is equals to n log a base b. Now here what we need to do is we need to multiply log n times this value f of n into log n whole power d plus 1, means log n is multiplied to the last term. This is for d is greater than equals to 0 values. Now if d is equals to minus 1, putting here minus 1 would make it 0, but we don't do that. What we do is f of n log into log n, means like this, log of log n, and if it is even less than that, then it is n power log a base b, means this value f of n. We can directly write this as f of n.